Hello, everybody. Thank you so much for joining me today. My name is Mark Mandel. I do developer advocacy for cloud, for Google Cloud Platform, specifically for games. I'm going to work on a project that I usually work on, which is Agones. And we're going to work on a little interesting problem that I realized the other day had become a regression. The way we like to handle things and the way we are handling things are a little bit different. So let's actually look at the regression. I think that actually, let's see if I can prove the regression first. I'm pretty sure I know exactly what's happening, but I want to prove it. Yeah, let's do that. So let's actually go to screen sharing. Beautiful. Let's have a look-see. So what do I actually need to do? Well, the first thing I actually need to do is I'm just gonna bug regression. Let's actually create a branch. And the regression that I want to look at is, let's see, build images. Actually, I need to. So I'm running. Sorry, all right. Let me. I'm doing setup. All right. So I have a cluster set up. It's on GKE. If I want to look at my nodes, I have a bunch of nodes. It's actually that's set up quite nicely, which is lovely. It's running 1.7, like lovely. If I actually want to look at it here, I haven't actually set up a test cluster in ages. Been doing everything on Minikube, but we have a bunch of where's what I want. I want to see my nodes. Here we go, beautiful. So here we go. So we have a bunch of nodes. We have a bunch of stuff on them. Each one has, these ones have about 4 CPU each. Beautiful. So we should be able to send a bunch of game servers up to them, which should be nice. I need to actually install this. So let's actually make gcloud auth docker. I just want to, these are all the development stuff that I have. So I'm just gonna, there we go, beautiful. Make -j for build images, push and install. So I'll let that run in the background. Actually, probably should have done this earlier, but it's fine. We'll do it now. It actually takes not very long. So hopefully that'll pop up pretty quick. So yep, I've got that cluster. And the thing that we're working on is basically when you have scales of like fleets of game servers, like these big groups of game servers, and we have what we call two strategies. We have packed and we have distributed. So when you're in the cloud, you want everything to be packed, right? Really close together so that you can scale down your cluster, right? So if you keep all your game servers in like a tight little group, that's great because it leaves behind empty nodes inside your cluster. There's nothing in them. That's awesome. And then basically, what's the word I'm looking for? And then basically, you know, you can remove those nodes if, you know, after a certain period, if people don't need them anymore, which is sweet. And so what can we do from there, which is pretty nice. But I realized we did a whole bunch of performance improvements, and it's been great. Like we actually can scale up and scale down massively faster than we could before, but we lost that pack strategy we had previously. It looks like basically what happens when you scale down is it just basically randomly picks things, right? It doesn't actually look at the pack strategy at all about how we want to do it. So we need to change that, essentially. So. There we go. All right, sweet. So that's installing. I can have a look. And I'm fairly sure I know exactly where the code is doing stuff. But when I sort of have a look, I think I have a pretty good idea. So while that's installing, it should be nice. We've got Grafana set up. We have a bunch of, here we go. Got a status. That's probably, here we go. Yes, we're up. Lovely. Beautiful. That's all refreshed from a few minutes ago. There we go. Let's just refresh that. So we have that, which is all lovely. So that's all set up. But what will actually show us things like where are we? What do I want? No, I don't care about that. Not allocations, but game servers. Beautiful. And then that'll actually give us a view into what's going on here. So let's have a look. Agones is doing stuff. It's probably, to be honest, creating these services for the ping server. Well, it's not doing that. I'm actually quite surprised. Let's see what's going on. It's stalling it now. Okay, kubectl get pods. Let's have a look. Controllers are running, ping services are running. That's good. What's taking so long? Usually it's the services. Oh no, everything's good. Oh, it's because those services are in a different namespace. They're in the Agones system namespace. All right, cool. So that is up and running. The thing I want to test, kubectl /f examples, simple UDP. There's two types of fleets here, so hold on, bear with me one sec. So we have in examples, simple UDPs, fleets. Oh, okay, so this is packed and distributed. Gonna do the packed one. This is gonna actually scale up a lot slower, which is fine. Fleet.yaml. Let's just fire that up. Sweet, that'll take a little bit to come up as it downloads things it needs to create. Yeah, beautiful. Beautiful, we have 3 of them. So let's kubectl scale fleet, what's it called? Simple UDP? Yep. Replicas. Let's just make, actually I want to make sure that we have enough room. So I'm going to create 50 of them. We have a look over here, which is actually quite nice. Let's refresh that page. We should see that we still have plenty of room. Which is all fine. I can actually even go as far as, okay, beautiful. So I can get GSs, beautiful. Yep, I have a bunch of them. Most of them are joined together, but we have some splits over to some other stuff, which is fine, which is actually really good. Sort by node. That's not right. What is it? It'll be status.node. No, couldn't find any fields in the list of objects. Game servers. I just want to do status dots. No. What does game server have? Oh my god. Bear with me. Install YAML. Helm, Agones, templates, CODs. GameServer.yaml. Thank you. What does node be? Node is status.node name. Thank you. Actually, this is good. 50 is actually a really good number. Interesting that it takes a while. Why does it take a while, I wonder? Oh, don't tell me internet's dropped. And my internet dropped because I hate my life. There we go, and we're back. All right, cool. And we are back, which is fine. Sorry about that. Small drop in stream. My Wi-Fi is flaky, so I picked it up, which is good. Okay, so we have... Here we go. All right, so sorted by node name. Oh, that's annoying that it doesn't show everything. Why doesn't it do that? -o wide? No. Fine? That's weird, actually. Okay, so it does that. Oh, weird. Okay, anyway, that's a thing. So if I sort it, I don't get the full display, which is silly. Why doesn't it do what I want it to do? So I press this node name, and then I get all this stuff. Oh my God, that's so irritating. Because what I want to see is that, right, that we've got a few here. All right, we have a few on some different nodes. Here we go. And here's the, actually IP is a little bit easier to look at, just because this. Now, what will probably happen? Okay, so actually, here we go. Here's an interesting test. We'll do it this way, which I think will show the regression really nicely. So we have 50 game servers that came up, and they came up pretty quick, which is great. You can actually see how quickly they came up, which is super nice. You can actually see that. Look at that. That's pretty nice. That shoots up pretty fast. And my brain just fell over. Okay, so we have how many not on JJLLZs, which is 1, 2, 3, 4, 5, 6. Right, there's 6 of them. Just making sure I get that right. 1, 2, 3, 4, 5, 6. Okay, so there's 6 of them. So what should happen under a pack strategy, and if we actually describe our fleet simple UDP, we have a look at our scheduling packed. What should happen if we like drop that down by 6 items is those, we scale up, those 6 ones that aren't on this node here should go away first. That's what we want, right? Like that's the important thing. But I'm willing to bet that they don't. I'm willing to bet that like a bunch of these. So if we scale this down, so replicas, yeah, here we go. So we scale this down to 44, right? We go down by 6, and we do that. GS. Right, some of those are getting shut down. Sweet, it's in a shutdown state. Oh, I actually really like that we made that change. Let's actually just have a look. So we're down to 45. All right, sweet. So if we have a look here, we can see that the ones that went away, like we still have these here. So we actually have like a whole kind of Swiss cheese problem going on, which is not good, right? For distributed systems, right? For say if you're running your own hardware or something like that, this is fine, right? You want your load spread out, right? Like, but for cloud, you want this tightly packed, and that's not happening. We just deleted a bunch of game servers that doesn't do what we want, and that's unfortunate. So yeah, we can see the same thing in the pods here, right? Like we still have these leftovers. So let's QCL delete the fleets. So we're gonna fry that. Watch that disappear, which is fine. And let's see if we can solve this problem. So I want to dig into the code a little because I think I know exactly where it is. So we have this thing called GameServerset. It's just under a fleet. It doesn't actually matter too much about it right now. GameServersets just control the how game servers themselves get scaled up and down. That's really it. It just makes certain things a bit easier. And inside our controller, where are we? We have a sync function. We have sync game server set, which basically just looks at what is the thing that we've declared in the YAML that we created, and like does it match up to the number of game servers that we have? And we have a whole bunch of caching stuff in here that enables us to do a lot of performance improvements, which are really nice. So some of the code's a little bit gnarly, but we do it for what's the word? We do it for performance reasons. So, boom, boom, boom. So where are we? So we grab, what do we do? So we sync game server set. So we get the name for the game server set that we need to sync on. We go and grab it. Sweet. Oh, actually, yeah, we do have a get. Okay, cool. That's a whole other thing. And we list game servers by game server set owners. Cool. Right. We go grab all our game server sets. All the game servers that belong to the game server set. Oh my God, that becomes a mouthful, doesn't it? We reconcile that with our updated server list. Oh, fun. How does that do? Let's just have a quick look here. So it returns a list of game servers or game server set, taking into account the complete list of game servers passed as a parameter in a list of pending creations and deletions. Okay, so this cache tracks game server creation and deletions. Whee! Fun. All right, sweet. And it just spits back out a list. So what do we do here? So we go through our game servers. If it's pending deletion, right? Okay, so then we get rid of it. Right. Okay, cool. It's not deleted. It's just the list. Okay, cool. Pending creation. So it hasn't, like, if the object was pending creation and now showed up. Okay, cool. Oh, I see. So we're just tracking what's being created and what's being deleted. This is all like performance stuff, right? Which is all sorts of fun. How the game server pending creation? We're not on the list. Okay, fun. Okay, cool. That's not my problem. And then we do this thing called compute reconciliation action, which is the really gnarly part. And it does lots of fun stuff. Okay. We're going to want to implement some fun things in here. So let's have a look in here. This does a really interesting this does a bunch of stuff. There's a lot of code in here, and it's kind of entertaining, I guess. So we take in a list of game servers, right, our current list. We say what is our target replica count? So how many game servers do we think we need? Max creations, like how many should we be creating in a single batch? Max deletions, how many should we be deleting a single batch? And max pending, which I am actually not sure what that does. I think that's max pod pending, like how many we expect. Yeah, max pod pending is the maximum number of pending pods per game server set, right? Like, so how many pods should be coming through? So right now it's like 5,000. These are numbers that we sort of just tweaked and played with and that kind of stuff. Cool. All right, so, and then it spits back. Where are we? What does it return? It returns the number of servers to be added, the servers that should be deleted, and whether or not this was a partial reconciliation. So basically, if there's more work to be done later. All right, so we've hit some of our top limits and stuff. Now, so what we do is we basically grab all our game servers and we start looking at them all. So schedule deletion is a function that says if the timestamp of the game server is 0, append it to delete. Great. Handle game server up, which basically says like there's a pod coming up. If up count is greater than target replica count, then schedule the deletion. Otherwise, up count plus, which is basically saying we create some more stuff, and we spit this up count back out. I believe, yes. Number of servers to add. No, or am I wrong? Yeah, this code's gnarly. So we up is how many game servers we have up. Got it. And then we work through. All right, so if we go through our list, if the game server is allocated, we can say up count is true, and then we continue. Fine. I don't know if actually continue is necessary, but that's a whole other thing. Because we're not doing anything else at that point. It just goes to the next one. And then we go and handle all other statuses. Right, okay, so we're counting all allocated ones first, for some reason. I don't know why we have continue here, but that's a whole other thing. Let's have a look at our test. Is there a reconcile action test? Computer, there we go, lovely. I assume that runs. Let's have a look. And it does. Beautiful. Everything passes. So here we go. Here's a fun thing. Oh my god, that had to happen at some point. Okay, so this continue shouldn't actually need to be here anymore. Let's run that test again. That seems like it doesn't need to be there. Yeah, because it's redundant. All right, cool. Okay, so if it's already allocated, then we skip it. Pod pending count, pod pending count. Okay, so all of these states are pre-pods being created. Scheduled, request ready. We set the game servers up. Right. And then if it's error or unhealthy, then we schedule it for deletion. Otherwise, we have no idea, and we assume it's up. Okay. So then we do... Basically, this is all like, right, like here, right? This is how many... Schedule deletion. I have a couple of ways that I could potentially handle this, but... So if I handle game server up... So basically, if our up count is less than our target replica count, then we work out the difference, right? And that's fine. Research plus pending, max pending, right? That's all good. If len of to delete is greater than max deletions, then we just sort it to be a bit shorter. I've actually got a few thoughts of how I want to do this. I'm actually thinking that we don't. So my original thought was sorting up front, but now what I'm actually thinking is I'm going to sort just on deletes. When I scale down, then I do it because then I hit that. So this is what I'm thinking. So to do track a delete count rather than a to delete array. There's a few things I want to do. I want to do write a game server sort implementation for fast sorting with utilities. And then what I want to do here, if delete count greater than 0, then sort and find appropriate game servers to delete. This might be a new function, which is fine too. Up until max deletions. Cool. I'm actually okay with this. I like this. I like this approach actually. I think this is. I had some concerns about doing like a sorting like on every one of these, and I think that would be slow. But I think this is actually the right way of doing it, and it's only on scale down, and that's the perfect time to do it because we don't actually scale down can be slower. Scale up, you want to be super fast, right? We don't want to sort as much as possible if we don't have to sort. But scale down, that's okay. Like yes, you know, like adding a couple of seconds, like, and I don't even think it's gonna be that. It's gonna be good. So I'm actually really happy about this. All right, so hold on. I want to get out of my. I'm just gonna commit this. Some to-dos that explain. Give me a strategy. Perfect. I'm actually gonna push this up too. Yeah, push -2 origin regression back. All right, cool. If I have to-dos, then I know what I'm doing. This makes me very happy. Okay, cool. So the first thing I actually want to do is write a function for game server sorting. You'll notice down here we do a little bit of sorting here using sort.slice. Sort.slice is not bad. The only issue with sort.slice is it uses reflection, which is really bad, which is not really bad, which is slower. Let's put it that way. It's slower than using the standard sorting. right, if we actually have a look at the code, let's have a look here. Is it sort go? Yeah, interface. Here we go. This does not use sorting. It does not use reflection from memory anyway. Yeah. Prenatal sorting slices. Basically uses polymorphism, which is super nice. Which is good. Right, so I want to have a default implementation of this so that we don't use reflection. Reflection bad. We can do that a lot faster. And let's move forward from there. So we have GameServer.go. I kind of feel like it should be in here, along with GameServer. Bear with me one sec. I'm just remembering how to do this. Go.org. Say sort. Yeah. Interface. Here we go. Strings. No, string slash. What am I doing? It's sorted. Sort data interface. The interface is this. Here we go. Len is the number of items in the collection. Less and swap. Wow, I haven't done this in a really long time. I've just been using the other one. So let's have a look at here. So type by age is no. There we go. So yeah, we can do this. I think in here, GameServer.go. What types do we have? Type game server. We have a game server list. Ooh, nice. So then we can do type. What do we call it over here? By age. Yeah, boring. We can do better than that. Ooh, how do I want to do this? This is actually an interesting question. What I'd like to do is be able to have a sorter that does it by comparator. Then swap. There's a less function here. So I actually think that I have an idea, but GameServer.go. Let's make a new file. GameServer sort. That's not what I wanted. New file. GameServer sort. There we go. So we're gonna say type struct. Yes. GameServer sort. Struct. GameServer sort. Sorts GameServers based on a comparator. Cool. And it's gonna hit. It's gonna have a list, which is an array of GameServers. And it's going to have a comparator. We're going to call it less, which would be a func. What does less look like on here? Just want to make sure I match it. Know what I want? Interface, that's fine. Swap. Less returns a boolean. Yep. But what we'll do instead is, where are we, sorry? Just the checks A, B, game server, and returns a boolean. Sweet. Do we need a constructor? I'm gonna go with no for now, actually. This is pretty much internal. The game server list to sort. The comparator function to use as this less is sorting function. Returns. Oops. Returns true if A is less than B. Pretty straightforward. Yeah, this should work. This should work. What I want to do now is code implement methods. Oh, sweet. Sort.interface. Oof. Ha ha ha. Perfect. I would like a pointer, please. That would be great. This actually, I think, is going to work. Why are you complaining? Type GameServers sort has both field and method names less. Less. We'll just call it comparator. glen is return. Oh, actually, yeah, that's fine. We'll look at this a little. I think there's maybe some cleanup we can do, but len g dot list. Oops. Less is return A equals g dot list. Oops, that needs to be G. That needs to be G. G dot list I. B is G dot list J. Return G dot list. Sorry, G dot comparator A. B. Swap. Temp is G dot list J and G dot list J equals G dot list I and G dot list I equals J. Sorry, temp. That looks right. Swap. Right. So that's all hooked up now. I think that gives this a swap a sorting ability. I'm trying to think if there's a better way of doing this though. Not really. I don't think so. Yeah, we'll use it and we'll see how we feel. Method, we'll call it sort, strangely enough. Sorts the underlying array and returns it. So G pointer to a game server sort returns an array game servers. Sort. G. And that should be fine. G pointer returns game servers type interface, does not implement interfaces methods missing len int. But I have all those. Oh, game server sort, my bad. Return g.list to make life easy. Len is the len function for sort.interface. Less is the less function for sort.interface. And swap. Sweet. I was thinking we might want to have some standard tooling or standard stuff for this. Well, let's test this first. We're just gonna do like a sort by name or something like that, something simple. New go file. GameServers sort _test. Lovely. Test name sort. Let's just go test sort. Go to sleep. So make sure no one's bugging me. Nope. Beautiful. All right, sweet. So test game server sort. I don't know why I put the underscore in there. I wish I could get rid of that. So I need some game servers. Array of game servers. Now here's an interesting question. When I go into here, controllers, this is an array of game servers or an array of pointers to game servers? This is an array of pointers to game servers. Oh, so annoying. Okay, which is fine, but like let's make sure we have that right. So list is an array of pointers to game servers, and what's annoying is that sometimes we have a list of pointers to game servers, and sometimes we have not a list of pointers to game servers, and it's very irritating because list functions will return an array of pointers to game servers. Anyway, that's fine. Push comes to shove, we will work it out. All right, give me an array of pointers to game servers. Where do I want? Sorry, my brain's not working. List array pointers to game servers. Okay, boom. Object meta. Make it A. Boop. B. Let's put these in weird orders. B. A. I'll do another one here, and we'll do it in C. I think I've done something bad. What have I done? Oh no, it's just that I haven't used it. Okay, cool. Let's actually drop this next line. All right, so that's in an odd order. And then what I want to do is just sort this by the name. I think it's pretty reasonable. Make sure that things work the way I expect them to work. Where are we? So, sort equals game server sort, which takes in our list and a func that is our comparator. Return a dot object meta dot name is less than b dot object meta dot name. Now we can do result equals sort dot sort. Sort dot not equal t listing result. Assert dot len t len of result should be the same as len of list should be the same as the result. Oh, I think I flipped this the wrong way around. There we go. All right, let's start with this. Let's see if this works. Broke something. All right, so game server sort cannot use. Whoops, where'd that go? Comparator and B. Where's my comparator? Oh, they need to be pointers, which means this also needs to be pointers because I'm dealing with pointers to game servers, not real game servers. Should not be. What's that? Actually, let's switch my layout real quick. It's my workspace. Layout laptop. Beautiful. Close project. Agones. There we go. Okay. So if we run that again. There we go, that's the bottom. Okay, should not be apparently they are the same. They should be not equal. List and result should be different. Well, you know what? Let's break it down. Sort doesn't, yeah, it just does the quick sort on here. All right, well, let's see what happens. So it should be ABC is really what we're expecting. So assert dot equal TA, that should be the same, and that should be results 0 dot object meta dot name. Cool. BC, and that should be 1, that should be 2. Let's run that. That runs. Oh, weird that did it. Oh, I just realized something. Yeah, I know why that failed before. That failed before because list actually gets updated by the sort function because it's stored inside of the thing. Yeah. Okay, but cool. But it sorts. Okay, sweet. ABC, beautiful. It does what I want. Fantastic. All right, so let's commit that. Actually, let's go import /w package. Make sure that's all nice and tidy. Let's lint it to make sure everything. Oops, wrong one. Beautiful. Oh. Excellent. We have a sorter. Cool. My brain just fell over. Okay. I have an idea. I have another idea. In here that I was just thinking about. So I do have this to delete, right? But what I'm wondering is if it's allocated. I think we might so I have this thought, which is we keep a list of the potentially deleted, potential removals on each pass through. Bear with me a sec. Yeah, because if it's not being deleted and it's not allocated, then it's potential deleted. Yes, here. Track potential delete potential game servers that could be deleted. Because we don't need all of them, so we might as well just track some of them. I kind of want to tidy some of this up a little bit anyway. wonder why we do that first. But fine, I guess. Why do we do this twice? We loop through twice. Handle all the other statuses. Cause schedulation. Maybe because we handle GameServer up on all the other ones. But even... Oh, yeah, we need to know. We want to know to start how many allocated we have. Got it. I could do it in handle GameServer up even. Because if we get to handle GameServer up, we could actually track it in there. So why don't we do that? I actually like that idea. Cool. I can work that, and then that doesn't... Maybe that's a bit neater anyway. That seems so good. How are we doing for time? Oh my god, we're not going to get this done. I actually thought I'd get this done in an hour. Oop, that's redundant. That's better. Cool. Actually, if we want to do that, we should call it a import alias and call it MetaV1. That's better too. All right, so that gives us that. What do I want to sort by? So I want to sort... I'm actually just wondering whether we want to have some standard sort comparators that we know work. Because then they can be tested, and that makes me happy too. So the thing I want to sort on is... this is going to be... Actually, I wonder if this is going to work. So you... Recorder... Where's... GameServer set state cache. So I have a thing that tracks... allocations? Allocation counter? No. Allocated and ready game servers currently exist on each node. Yeah. That's actually exactly what I need. And where does that get created? Oh man. All right, so I have a thing that has allocation counts and just tracks them. And I can get counts, and I get a node count, and that's actually perfect for exactly what it is that I want. And that's how allocations work. Problem being, I just realized, that's not available here. I need the allocation counter. Does this fit our run pattern? It doesn't, but we could make it fit its run pattern. Okay. GameServer former. Blah. Got it. All right, so this is gonna have to get pulled out because this is currently in here, and I have a feeling it sets it up. Where does this get created? Allocation counter. Is there allocations? Here we go. Allocation counter. And controller. game server allocations. This is going to break some other stuff that I have, but that's fine. Vacation trees. Yep. My internet dropped again because fun. That's all right. We'll keep on ticking. That's all right. I gotta finish soon anyway. New controller. Here we go. You do not take. This is fun. Okay, so you create the counter. And continue. So this needs to get pulled out. Whee! All right. Allocation counter needs to be removed so that we can use it elsewhere. Oh my god. Things always get bigger than what you think, right? More to-dos and stuff. All right, so allocation counter needs going to get pulled out. It's actually not. It's more of a node counter. I'm actually going to rename it to. Where am I going to put this? This is actually really interesting. All right, quick. All right, so we have the sorter. Beautiful. That's looking really good. I need to get the counter out, I think. All right, so let's thinking this through, because we've got APIs, stable v1, game server sets, game server sort. Right, this seems okay. Maybe I think I'll leave this the way it is. It's a nice implementation. We'll keep it as a test. We're good. Like, I think that's fine. What we need to do now is pull out I'm just going to pull all that out. We need a way to do this a little better. All right, so game server allocations. We have an allocation counter. That's not where it should be. So, this is interesting. Where do I want to put this? Util, maybe? No, I don't like that spot. Server metrics is here. I'm just going to call it new directory counter. Yeah, that works for me. Game server allocations. We're going to move that to counter. Let's see what that does. Okay, so controller allocation counter, like you just broke, just fine. We're gonna rename you. You are not that anymore. It's not really an allocation counter, really. It counts how many allocated and ready game servers. It's more of a game server counter, really. Maybe it should actually be in game servers. Now that I think about it, yeah, I actually like that idea a bunch better. So let's do that. Delete that. You are going to get renamed to game server counter. Yep. All right, game server counter. And game server counter. Customer allocated, running game service, calling destination node, scheduling, allocations, fleet management, mostly under a packed strategy. So we're going to call it a game server counter. that, and we'll call it a new game server counter. Refactoring preview. That all looks pretty good. Yeah, we broke a bunch of stuff, but we'll fix it, which is fine. Basically, I want to pull this up into main, and we'll see how this goes. All right, sweet. So that game server counter, blah blah blah. Let's I don't want to change it at all. The other thing that we want to have a look at here is command, controller, main. Beautiful. We have a interface. Here we go. Runner takes these two functions. Beautiful. Game server counter. So we've got our run. We don't take workers. Boom. I don't think we block on here. No. We just wait for cache sync when we set up originally. Yeah, exactly. Non-blocking. Run function. Beautiful. Cool. All right. What time we got? Oh my god, we only have a minute left. No! Let's see if this is gonna continue. All right, so that's pretty good. Let's have a look. Allocation counter becomes a game server counter. Yeah, let's just replace all. It'll be fine. Something broke. Oh, we don't have a default namespace. Because that was in here already. Helper test. Where is that used? All are through there. Okay. I don't think I use it in here at all. Oh. Interesting. So yeah, there's a type in there with node counts and stuff that's gonna need to be pulled in. And come back to that. That's a whole other thing. I might just pull this out, delete that. Controller test. Yeah, that's a whole other problem. And then this here. And one redeclared in this package. Let's have a look. Oh. Alright, well then we'll come back to that. Yeah, we have a bunch of bugs. Okay. I'm gonna have to stop here, actually, unfortunately. Ah, that's really unfortunate. I broke a bunch of things. Alright. Broke a bunch of things. Alright, sweet. I'm gonna have to stop here, unfortunately. I need to run away. But I'm gonna continue working on this. We'll see how it goes. So, but this is heading in the right direction, and I'm pretty happy about it. But I just need to pull some things apart a bit better, do some refactoring, and I think it's gonna come together. Otherwise, yeah, check me out on the Twitch, which you are on right now, or if you're watching me on YouTube, check me on vice versa. So Twitch, you can see the link below in the summary if you're watching on YouTube. If you're watching on Twitch, you can see below my details for YouTube. You can see my Twitter stuff. I'm gonna try and stream a bit more now that I'm back in the US, which is nice. And hopefully I will catch you all later. All right, I'll see you later.